Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com, and this video is another in the series of RHCSA practice videos for the Red Hat Certified System Administrator exam. I want to thank you for taking the time to watch, and something to remember is that these are not designed to be authoritative videos as far as the information. However, I am trying to make this as accurate as possible. Remember, the point of these videos is for me to practice the objectives and try to explain the concepts and such, kind of as a test for me to see if I think I know what I'm talking about. So hopefully I'll do well on the exam. Also, I can see them as being beneficial to viewers who are also going after this exam. I might present things in a way they haven't considered before, and so that way I might get another idea of how to practice something or how to approach something, because the goal is for all of us to learn, to be able to benefit from one another. Feel free to comment on the video, in particular if you hear something that I say that is incorrect, because I would like to be be fixed with that, so I have correct information, and also it can help prevent confusion with folks watching the video. As always, if you enjoy it, make sure you click like on the video and subscribe to the channel. Ring the bell when you do. So getting into it, this video is going to be about the objective within the Understand and Use Essential Tools category, the List, Set, and Change Standard UGO/RWX permissions. So I'm here in my CentOS 8 machine. Let's go into the terminal, if this will behave for me. Alright, a little different setup from my last video. I decided to go back to Avert Manager on my laptop, but I've changed the resolution to hopefully make it a little bit nicer to see, so we'll see how well it works. So permissions, this is always a fun thing no matter what operating system you're under, but in Linux it's not super complicated, which is nice. And what I mean by this, I'm going to create a test file. So I'm going to do ls-l. The L is for long listing, and the nice thing about long listing is that it will it'll give you the permissions. And the let's see, octal notation is that. I can't remember off the top of my head the name of the alphanumeric notation. I just know it was octal notation. But it gives you the permissions for a file. You can see my test file here. We have RW, RWR, and these refer to different bits for information. The very first bit here indicates that this is just a file. Otherwise you would see D for directory. If it was a soft link, you would see an L. I want to think block devices have something special. Let's take a look. So ls-l dev. Yeah, block devices and character devices have a little different thing as well. So let's go back to ls-l. All right, and after that, you have 3 bits that indicate user permissions. You have 3 bits that indicate group permissions, and 3 bits that indicate other permissions. So user is, as it says, this is the user owner of the file. This is what permissions that user owner has. Group is for the group owner of the file, and then other is for anything else on the system. So in the case of test file here, my user account, Eddie, owns the file. The group account, also called Eddie, is the group owner of the file. And other would be everybody else. I, as the owner, have read-write permissions. People in my group, which is just me, have read-write permissions. And then anyone else on the system has read permissions. All right. So to kind of test these permissions out, I'm going to create another user. I'm just going to call this test user 1. And we're going to change its password. SWD test user 1. It's going to complain about my password. All right, and I'm going to make another terminal window here. And we're going to sudo or substitute user into test user 1. All right, so if I were to go into this directory, so this will be home Eddie. Oh, can't do that. Wonder why that is. Probably a permissions thing. So let's go up a directory. And notice the permissions for the Eddie the Eddie directory within home. The user Eddie has read, write, execute permissions, but the group Eddie does not have any permissions, nor does other, and makes sense. I'm the test user, or to do who am I, test user 1, cannot navigate into this directory. So that's one thing with permissions. To be able to navigate into directory, you have to have execute permissions. Now, execute does not mean that you can start messing with files and such in the directory. It simply means that you can navigate into it. So what I'm going to temporarily do is grant other the execute permission for my home directory. Now in a production environment, I don't recommend you do this, but this is just a practice for working with this concept. So there's a couple ways of doing this. I'm going to stick with the non-octal way first, and then near the end of the video I'll show how you would do these things with octal notation. So if I wanted to change the permissions on this directory, the command I'll use is change mode, literally, but chmod. And what I'm doing is I'm going to grant the other permission group the execute permission, so O plus X. So we'll do that to Eddie. All right, if I do ls-l, you see that that bit has changed to being an X for execute. And let's see if I can change directory into home Eddie now as the test user. Lo and behold, I can. All right, let's see if I can list the contents. Nope, can't list the contents. All right, let's see if since I know the name of the file is test file, let's see if I can just cat test file. All right, I can cat test file. So the reason why I can't list the contents is because of the permissions. I only granted myself execute permissions for this directory. So let's go back over here, and we're going to grant other read permissions as well. See if that allows us to do ls. I believe that it will. So other plus read for Eddie. All right, and now we can read. So that's kind of real time how those permissions are working. And then if I were to ls-l, we see that the test file has read permissions for other. But notice how even when you didn't have read permissions on the directory, I couldn't do ls. I could still read the test file. Now, the other people in the other category, or user accounts in the other category, can't make changes to this file. All I can do is read it. So if I were to try to vi test file, this says this is a read-only file. So let me go in here. I'm getting a warning saying I'm changing a read-only file. And let's add some, here's more text for text for a test file. And I'll try to close that and write it. And it says read-only option is set. To override that, let's add the exclamation point. So let's see if that works. I need to do exclamation point first, I believe. Oh That wouldn't make much sense because that would tell me I'm trying to run a command named X. Yeah. So let's try to use X again, exclamation point. Yeah, cannot open file for writing, which makes sense because we don't have the permission. So let me do Q. All right, now if I were to change the permission on this file to allow for write, then we'll be able to do that. So let me go back over here. Change mode O plus write for test file. And if I were to VI in the test file, notice I'm not getting any more warnings about the file being read-only because I've granted it write permissions. And then I can close the file with no problem. And if I were to cat the test file, then I see the other line of text. So real basic permissions. I'm doing this for other, and you can do this for group and for user as well. One of the advantages of using groups is, say you're in a scenario where you as the owner need to be able to access all the files, and there are other folks that need to do that as well, and they all maybe belong to a finance group or development group or whatever. You can grant the group permissions for that. And so let us do that. Let's make another group here. I'm actually going to change directory out of that. And we're going to make a couple of changes here. First, we're going to make a group. So group add, call it test users. Oops, sudo group add. Now we're going to add the test user 1 user to this group. User mod for that. Oh wait, need to put the group name. So test users, test user 1. Alright, and if I were to do ID test user 1, not sure if it'll show it to me with an unprivileged account. It will. Alright, so test user 1 is now a part of two groups. Their own group, test user 1, and the test users group. So let us reset permissions back to the way that they were. So ls-l, we're going to change test file, chmod or change mod, other minus write, getting ahead of myself, ls-l test file. There we go. Now that's back to the way that it was. Let's go up a level, and we're going to change, we're going to take away minus read execute on Eddie. Alright, so now we're back to the normal permissions. And case in point, if I were to try to change directory into home Eddie, I'll be denied. If I were to try to cat that individual file, can't do that because can't get into we can't traverse into the directory in order to be able to make that happen. But what I want to do, let's say there are multiple people in this test group, and I want to allow this test group access to my home directory. What I can do here is I'm actually going to use the chown command, which is going to be changing ownership, and I'm going to change the ownership of my home directory from Eddie to the test users group. So chown, I'm not changing the user owner, I'm just changing the group owner, so I'm going to leave a space, colon, and then the group. So normally you would have user colon group. Sometimes you will see dots. I do not recommend using dots because that can be ambiguous, because it's possible to have dots in a username. Colon, I'm pretty sure, is the the formatting standard for Red Hat to be able to do that. But since I'm not changing a user, we're just doing :group, and that'll be test users, and we'll do Eddie. Might have to. Odd, not expected to be able to do that. So let's use sudo test users Eddie, or sudo chown test users Eddie. There we go. Just curious. I expected being the owner of the folder to be able to do that, but I guess from an administrative perspective, you probably wouldn't want to have that happen. You would rather have the system administrator be able to change ownership of files in the home directory. But that was kind of odd. Another reason why I want to do these videos is kind of a little troubleshooting thing on the exam. If something's not working, it's like the old joke. Patient's in the doctor's office. Doctor's like, I want to give you a vaccine. The patient says no, and the doctor's like, sudo give vaccine. Patient says okay. Anyway, so now ls-l, we have changed that to test users, and the test user still doesn't has no permissions on that. So what I want to do, see if I can do this without sudo. So change mode, I was able to do others without it, so I imagine group as well. I'm going to use group plus read execute on Eddie. Yep. Alright, so now I should be able to go into home Eddie. Odd. I think I know why. Nope, we're there. Test users. Part of me tells me that I do need to do that because the group has changed and password, and when this test user logged in, it has not reread those particular files, etc groups, etc groups, etc password d. So let's exit su-l test user 1. I believe this will work now. Yes, I'm in. So even though I added the user to the group, user still has to log out and back in, so that way the operating system has read all of the necessary groups that this user is going to be a part of. And if I were to do ls, I see our test file. And then I should be able to read this because other still has read access. Notice that since I did not do anything recursively with the chown command, nothing has changed as far as ownership here. The -R is the flag for recursive work with this, should you need to do that. Only other thing as far as this being standard UGO permissions, I'm not going to get into sticky bit and set GID. I think there's a separate objective for set GID, which is still a part of permissions, but it's not what I personally would consider just the standard permissions. What I did want to mention was the octal permissions. So each of these bits, the read, write, execute, has a numeric value, and the read is equal to 4, the write is equal to 2, and the execute is equal to 1. So a quick way to be able to change permissions, not necessarily quicker than using the alphabetical way, but a different way. Let's say that I know for a fact that I want test file to be read, write, execute for both group, user, but nothing for other. All right, and so what that would be, read, write, execute, 4 plus 2 plus 1 is going to be 7. So what I can do with that is go, well, I don't have to go into the directory, but it makes life a little easier. I can do 770. All right, and 770 stands for those three sets of permissions: user, group, and other. 7 would be read plus write plus execute. 0 would be nothing. So if I were to do that to test file, you have read, write, execute, and nothing. And then if I were to try the cat test file, can't cat that anymore because I removed the permissions. So let's change this back to the way that it was. So the way that it was, which I still have on this here, read, write, read. So that would be 6. Read plus write is 4. 6. Read plus write is 4. And then 4 for read. So 664 test file. And so now that matches, and I can again cat test file. So if I were to do the what I wanted to do without octal notation, that would be a little bit complicated. I believe this is what I will do. So I'm wanting to add execute to read to user and group, and I want to remove read from others. So I think this is what I would, how this would work. So I'd have user group plus execute, I think other minus read. I believe that's how that would work. Let's see if it works. All right, ls-l. All right, and that did it. So notice that syntax there, rather than, all right, and then if I were to want to change back to the way that it was, then I would have user plus group minus execute other plus read test file. And we're back to the way that we were. So for me, it kind of depends on what I'm doing. If for that example of I know that I want all permissions for two groups and nothing for another, it might be easier for me to use the octal notation, but otherwise the other notation works. But the key to remember is that octal notation is set by adding whatever the value of the permission is. Read is 4, write is 2, and x is, or execute permissions rather, is 1. One other thing as far as execute permissions, let's say you have a script. In order to be able to run that script, it has to have execute permissions. And if you notice, when I've made a file, let me make another file here, test file 2. If I were to ls-l, notice that it doesn't have execute permissions by default. And the reason that is because of umask. And let me look at the objectives real quick just to see if there is a separate one for umask, of which I'll do a separate video. Otherwise, I will briefly discuss umask and how that works. All right, I'm not seeing one, so we'll dive into umask for a couple minutes. So this umask 002, what this is telling us for a file, if we make a new file, the first 0 is representative of like UID bit that I'm not going to cover in this particular video, so we're focusing on these 3 here. And what this is telling us is we want to we're not masking any permissions, and mask means to make not available. We're not masking any permissions for users, we're not masking any permissions for groups, but we are masking the write permission, that's 2, the write permission for other. By default, files begin with 666 for permission. So they have read, write, read, write, read, write. And then what the umask tells us is when we make a file, we're going to mask some or none of these permissions. And so in the case of test file, we're not masking any permissions for user group. So we have read write, and we're masking the write permission for other. If I were to make a directory, notice how it now has testdir here, read write execute, read write execute, read write, read execute. Directories come from a default of 777, which will be read write execute. And then if I were to apply the mask 002, 0 is we're not masking anything for user, we're not masking anything for group, we're masking 2 for other, which 7 minus 2 is 5. 5 is going to be read plus execute, 4 plus 1. All right, so the question is, how do we set this? Well, for a one-off session, you can set umask. You can set umask just by doing, I might have to do sudo. Let's see. Let's hide the write permission for both user and group. So 222, and we'll keep it the same as other. Yep. All right. So umask 222, and so let's make another directory. There we go. Testdir 2. Notice how the write permission has vanished. All right. Now, this is not going to survive a reboot. So if I were to restart my machine, umask is going to go back to normal. And as we know with the RHCSA, whatever changes you make, you need to be either you have to make it survive a reboot, which I would imagine you have to, because that point seems to be beaten into us a good bit, or you have to at least know how to make it survive a reboot. So there's two places where we would need to set this. And the first, let me go into the etc directory. The first is the etc profile. Where's my etc profile? Should be in this directory. Oh, there it is. Profile. And if I were to, I gotta do sudo for this, vi into etc profile. VM's running slow. All right, I'm apparently fat fingering this. Let's try it one more time. There we go. All right, so remember the etc profile are the defaults for a login shell. And there's all sorts of stuff here. And there's a section that will be dealing with umask. And notice this says if the user ID is greater than 199 and the group name is the same as the username for the primary group for a user, which basically this means that non-privileged users, so above 199 and group name matches username. Notice I had Eddie over here in this window. We're going to set the umask at 002, which is what it was. We're not masking anything for user and group, and we're masking write permissions for other. Else, so this would be privileged accounts, and by privileged I mean root and the like, then we are going to mask both the group and user. There's a motorcycle outside, you can probably hear that on the recording. The group and user, we're going to mask the write permission. That's really all it is. It's just the fact that umask, even though just running umask isn't persistent, but since it's a part of the etc profile, that's what's going to make that persistent. The other file that you need to alter, let me quit out of this, is the etc-rc. This is going to be for your interactive shells. And if I were to scroll down a bit, we're going to find a very similar code block. Go back up here where we have, If the user ID is greater than 199 and username equals primary group name, then umask will be 002, otherwise it'll be 022. So a bit long-winded, and you would think list set change the standard UGO or RWX permissions that would be a fairly simple topic, but there's a decent bit to go about it. And as I'm thinking about it, we definitely listed them: ls-l set, set and change. Well, set, we could use change mode for that, or getting into umask, we did make a change with the umask, and then of course we can do this in these files, reboot your machine, and that change would persist. And then to change the permissions, obviously change mode for that. And we looked at change ownership as well, just to demonstrate how you can use group permissions. So I hope you found this useful. Again, the goal is a practice session for me, and possibly an enlightenment session for those that are watching it, or a test session for me as far as those watching. If I made a mistake, feel free to comment about that. As always, thanks for taking the time to watch. Remember, if you enjoyed the video, like the video and subscribe to the channel, ring the bell when you do, and I will see you the next time.